Hello guys, welcome once more to another video in our YouTube channel. So in this video we are going to be looking at June 2023 further mathematics paper 2 question 9 solution. It was from the topic recursive sequences. Before we start, I would like to bring in some informations to you guys. First of all, we have WhatsApp revision groups where if you're preparing for the GCE, you can get to us via the number on your screen and you're going to be added to the various WhatsApp revision groups for the various subjects. For those of you who want to prepare for preparatory for entrance examinations into professional schools, you want to write concourse, pre-registration is ongoing for those who want to do both online and on-site preparatory classes in all the regions in Cameroon. So for those of you who want to register online, you are going to be using our platform. For those of you who want to register on-site, you are going to be taught physically. There is also a possibility for you to register both online and on-site. Okay, so for those of you who want to pre-register for prep classes, you can get to us via the number on your screen. Prep classes are very important for those of you who want to write competitive entrance examinations into professional schools, be it engineering, medicine, or teaching. Okay, so after your GCE, you're going to face these examinations, and you have to be well prepared to pass these concourse. Speaking to you, I am a fifth year engineering student at the National Advanced School of Public Works, Department of Topography, so I better understand these things. So no matter the region you are, you can pre-register. Pre-registration is basically basically you booking a spot for the preparatory classes, both online and on-site. It is totally free. I just need to know your name, your school, the concourse you want to write, or if you need an orientation, I'm going to orientate you. Okay, and when you start your prep classes, we the MAFA team, we are going to follow you up both online and on-site. On-site means if you're going physically, there will be a team that will be sent to your prep classes, which is going to follow you up. All right, so without me wasting much of your time, let's get started. All right, so I'm going to iterate a little bit on this topic, recursive sequences. This topic since 2018 has been coming in further mathematics paper 2 and is always allocated for a minimum of 17 marks. This topic is very important. It is very broad, very vast, and paper 2 of further mathematics is actually 50% of the whole GCE. So 1 mark in paper 2 is equivalent to 0.5% of the whole GCE. This question will normally carry 20 marks. That is, for most of the years it carries 20 marks. So imagine scoring 20 on 20 in this question. It is very possible. Scoring 20 on 20 in this question means that you are already having 10% of the whole GCE. So you have to be very, very vigilant, because the other questions, the other topic which is also as important as this topic is further curve sketching, which is also 20 marks. So imagine yourself scoring 40 marks on the 2 questions. That is already 20% of the whole GCE. And if you master further mathematics, further pure mathematics, then you're going to definitely pass the GCE, because it is 50%. And when you go to paper 1, which is 20%, you find mostly further pure mathematics questions. When you go to paper 3, you realize that you are just applying the further pure mathematics knowledge that you have. So make sure you prepare effectively for the GCE in further mathematics strategically by, first of all, starting with the topics that carry more marks and you master them. This is one of them: recursive sequences. So there are a lot of videos in this channel that will help you to master recursive sequences. I think there are about 13 videos solving GC equations, solving mock questions, a tutorial lesson, the full lesson on the topic. So if you're new to this channel, you are already saved. You have nothing to worry about. Okay, just make sure that you follow the videos, you comment. If you have a difficulty, you indicate. If you have a question that is bothering you, maybe if you're already added to the WhatsApp group, you send your question there. And believe me, if you work in that way, you are going to ace further mathematics. All right, so let us continue with what we have for today. So I'm going to go proper into the question itself. Okay, the question reads: a recursive sequence is defined by, we have u1 is equal to 3, u2 is equal to 13, un plus 1 is equal to 3un plus 4un minus 1 plus 2 raised to the power n, and n is in a set of natural numbers. Okay, Roman 1, show that un plus 1 plus un plus 2 to the n is equal to 4 times un plus un minus 1 plus 2 to the n minus 1. That is 1 mark. Another sequence Vn is defined by Vn equal to un plus un minus 1 plus 2 to the n minus 1. Roman 2, show further that Vn is a geometric sequence. 2 marks. Roman 3, show that V1 is equal to 9 on 2. 3 marks. Roman 4, find Vn in terms of n. 3 marks. Now, given also that un plus 1 minus 4un minus 2 third times 2 to the n is equal to negative into un minus 4un minus 1 minus 2 third times 2 to the n minus 1. Roman 5, show that un plus 1 minus 4un is equal to 1/3 into 2 to the n minus negative 1 to the n. 3 marks. And hence or otherwise deduce that 5un is equal to 9 on 2 times 4 to the n minus 1 on 3 times negative 1 to the n minus 4 on 3 times 2 to the n. 2 marks. So this was actually question 9a. Question 9b, I think it carried 5 marks. So if you add all, you have 1 plus 2 3 plus 3 6 plus 3 9 plus 3 12 plus 2 15. So, and then the other 5 marks now for the B part, which was basically on series. It was not on sequences. That is why I have not included it here. So you see that sequences and series carries 20 marks. So if you master the topic very well, you have nothing to worry about. So this video is one of the videos that you're not going to find anywhere, okay, because I took my time and I solved these questions. I used a lot of methods that you are not going to see in other videos, that is in the previous videos that I have done on sequences and series. So make sure you take your pen, your jotting book, if in need of a calculator, and you follow the video keenly. Don't miss any part of this video. Make sure you follow the video from the beginning till the end, because what I say is more important than what you see on the screen, because I cannot put everything I say on the screen. It's going to make the slides to be too saturated. So make sure you listen to everything I say, because that is what is more important. What I put on the screen is basically displaying the solutions that I have drafted, but now the explanations are basically more important than what you see. All right, so let's get started with the solutions. So we are going to begin with solving Roman 1 and Roman 2. Make sure as you watch the video, you like the video. At the end of the day, make sure you share the video and you also comment if the video is helpful. If you need other videos, you comment the videos that you need in the comment section, so that we are going to react. Okay. Alright, so let us begin solving Roman 1 and Roman 2. We begin with Roman 1. Roman 1 says that show that un plus 1 plus un plus 2 to the n is equal to 4 into un plus un minus 1 plus 2 to the n minus 1. The sequence was already defined recursively and the information is given above. Okay, so when you see something like this, okay, the first thing to start is you start with the left hand side. You don't prove from right to left, you prove from left to right conventionally. Though we know that if A is equal to B, then B is also equal to A. But when we are proving, try your best to prove from left to right. So I start with my left hand side. My left hand side, un plus 1 plus un plus 2 to the n will be equal to, now I come to my recursive definition and I copy out the un plus 1. My proof has a un minus 1. That is why I must come and use a un plus 1 that was given to me originally. So un plus 1 that was given to me originally is 3un plus 4un minus 1 plus 2 to the n. Now I need to add these two other terms, which is un plus 2 to the n. I bring like terms together. I take 3un plus un, it gives me 4un. Then we add it to 4un minus 1. Now 2 to the n plus 2 to the n is 2 of itself. Okay, because we are adding something to itself, so it must be 2 of itself. If we continue the simplification by factorizing 4, factorizing 4 from 4u to the n just means that you need to take 4u to the n and you divide by 4. You are going to be left with 4un divided by 4. You are going to be left with un. So factorize 4 from here, we also take 4un minus 1 divided by 4. You'll be left with un minus 1. So factorize 4 from this term, you take 2 into 2 to the n divided by 4, which will give you 2 to the n divided by 2. We are doing this so that if you multiply all through by the 4, we get back the previous step. And clearly, if you multiply, you're going to get back the previous step. So from here, we can just conclude directly that un plus 1 plus un plus 2 to the n is equal to 4 into un plus un minus 1 plus 2 to the n minus 1 if you apply indices here. So we have had the 1 mark. Okay, so let us move on to Roman 2 of the equation. Roman 2, we have an information which says a new sequence is defined by Vn equal to un plus un minus 1 plus 2 to the n minus 1, and we are asked to further show that the sequence Vn is a geometric sequence or a geometric progression. So what is a geometric progression? A geometric progression is basically a progression where the ratio between any two consecutive terms is a constant. We refer to that constant as a common ratio. Now, the first thing to note is that in further mathematics or in mathematics at the advanced level, we don't replace terms and then we divide to get a common ratio or to prove. We can do that to get a common ratio if it is a paper 1. But if it is a paper 2, to prove that something is actually a geometric progression, we need to use the n plus 1 term and the n term. Okay, so I need to show that the ratio between the n plus 1 term, which is vn plus 1, and the n term, which is vn, is equal to rho, and rho is called the common ratio of the geometric sequence. So if I am able to prove that vn plus 1 divided by vn is a constant, then I have proven that the sequence is a geometric progression. For those of you who have difficulties in these basics, make sure you review the very first video that I uploaded concerning sequences and series. I am going to include the links to all the videos on sequences and series in the description of this video so that you can easily access those videos and you watch them in the order that I have listed them. Okay, so since I need to prove that vn plus 1 divided by vn is equal to a constant, I must start by finding vn plus 1. Okay, so since vn has been defined as un plus un minus 1 plus 2 to the n minus 1, to get vn plus 1, I just need to increase every n by 1. So in the place of n, I replace it with n plus 1. In the place of n, I replace it with n plus 1. In the place of this n, I replace it with n plus 1. But now since there's a minus 1 here, I just have n. In the place of this n, I replace it with n plus 1. And since there is also a minus 1, the 1 cancels, the 1 in the n plus 1 cancels with this minus 1, and you're left with n. Now, you clearly see that we have already proven in the previous question that un plus 1 plus un plus 2 to the n is 4 times what? Un plus un minus 1 plus 2 to the n minus 1. So it means that what we have here is just equal to 4 times un plus un minus 1 plus 2 to the n minus 1. Okay, because we have proven it in the previous question. But you can see identify that what is in bracket is still the sequence Vn. That is the Vn that was defined. So it means that Vn plus 1 is 4 times Vn. If I want to now find Vn plus 1 divided by Vn, I can just divide both sides of this equation by Vn, so that I get Vn plus 1 divided by Vn to be equal to a constant. And we conclude that Vn is a geometric sequence or a geometric progression. So with that, we have concluded 4 is a constant, right? And clearly 4 is going to be what? The common ratio of the geometric sequence V of n. Alright, so let us move to the solution to Roman 3 and Roman 4. Okay, Roman 3 is allocated for 3 marks. It's a proof. Show that V1 is equal to 9 divided by 2. That is what we have to show. Okay, so first of all, we have to know that our Vn was un plus un minus 1 plus 2 to the n minus 1. Okay, so if I replace n with 1, I'm going to have V1 to be what? U1 plus u1 minus 1, which is u0. I'm replacing n with 1. Then here I replace n with 1, I get 1 minus 1, which is 0. So I get V1 to be u1 plus u0 plus 2 raised to the power 0. Okay, now you realize that 2 to the power 0 is 1. We know what u1 is. u1 was given to us originally in the equation, but we don't have u0. So the next plan is to find the value of u0. How then do we find the value of u0? I need to use this recursive definition of un plus of the sequence un. So if I replace n with 1, right, I'm going to have that u2 is equal to 3u1 plus 4u0 plus 2 raised to the power 1 if I replace n with 1. I'm doing this because I know u2 and I know u1. They were given to me originally, and since I want to find u0, is going to be very possible. Okay, so my u2 was 13, my u1 was 3, and then now I have 4u0 plus 2. So when we simplify, 13 minus 9 is 4, 4 minus 2 is 2. So it means that 2 is equal to 4u0. If 2 is equal to 4u0, it means that u0 is equal to 1/2. We now replace in this equation so that we get our v1, our u1 is 3, our u0 is half, and then plus 1. If we simplify, we are going to get our v1 to be equal to 9 divided by 2, which is what we are required to prove. Okay, now Roman 4, we need to find Vn in terms of n, and it is allocated for 3 marks. So in the previous question, we saw that Vn plus 1 divided by Vn was equal to 4. Okay, and we have also seen that V1 is equal to 9 divided by 2. It therefore means that from the first statement here, we actually proved that Vn was a geometric progression, and we know the n term of a GP is basically what? Is basically V1 r raised to the power n minus 1, since our n is beginning from 1. So Vn is V1 r to the n minus 1, where V1 is the first term and r is a common ratio, and this r is the same as Vn plus 1 divided by Vn, so it is 4. It therefore means that our Vn will be what? 9 over 2, since it is V1, times the common ratio, which is 4 raised to the power n minus 1. That is Vn, that is the sequence Vn in terms of n. But now there is something. When I was producing this solution, I read the equation very well. The equation did not say that we should state Vn in terms of n. Kind of, the equation is saying we should find Vn in terms of n, and it's allocated for 3 marks. So I asked myself, will the marker actually mark this solution here and give a student 3 marks? And then the answer I gave to myself was no. I don't think any marker will actually allocate 3 marks for this question, okay, and expect the student to actually do this. So I came up with another way of answering this question. That is, let us actually develop the sequence Vn. Let's not just use the fact that Vn is a geometric progression, so we have that Vn is equal to V1 arrow to the n minus 1. I now actually tried to develop the proof. So let us see the proper way of actually finding Vn in terms of n. Okay, so I begin with the fact that Vn plus 1 divided by Vn is equal to 4. Now I need to go back down. If Vn plus 1 divided by Vn is equal to 4, it means that Vn divided by Vn minus 1 you see give me 4. It is a geometric progression, so the ratio between any two consecutive terms is a constant, and that constant is a common ratio. It does not change. Vn and Vn plus 1 are consecutive terms, mean that because after Vn it is Vn plus 1. Now Vn and Vn minus 1 are also consecutive terms, because after Vn minus 1 the next term immediately is Vn. So I'm going to iterate downwards. So if I take Vn minus 1, I'm going to use Vn minus 2. So Vn minus 1 divided by Vn minus 2 should also give me the same constant. Okay, if I use Vn minus 2, I will compare it with Vn minus 3. So Vn minus 2 divided by Vn minus 3 is also equal to that same constant. So if we go down right up till the beginning, which I can begin with V3 and V2, and then I end with V2 and V1, then this will always work. Now you realize that in the first equation here, Vn is in the denominator, but in the second equation, Vn is in the numerator. In the second equation, Vn minus 1 is in the denominator, but in the third equation, Vn minus 1 is in the numerator. So if I think of multiplying all these equations, then something is going to happen. So if we multiply, then we are going to take Vn plus 1 over Vn times Vn over Vn minus 1. We multiply the right hand side right up till we end at V3 over V2 times V2 over V1, and multiplying that is equivalent to multiplying all the 4's on the right hand side. And we are going to multiply how many times? We are going to multiply the 4's n times. Okay, why are we going to multiply n times? Because check the base term. Here is V1. From V1 to Vn there are n terms, or from V2 to Vn plus 1 there are still n terms. So if I'm multiplying all the 4's, I'm going to multiply the 4's n times. So you now realize that the Vn in the denominator of the first term will cancel with the Vn in the numerator of the second term. The Vn minus 1 in the denominator of the second term will definitely cancel if I wrote down these terms here, which I have just excluded to make the solution not to be cumbersome. If the Vn minus 1 in the second term will cancel with the Vn minus 1 which will be in the numerator of the third term, and so on and so forth. So before this V3, there's going to be a term before the V3. Okay, the term before V3 over V2 is going to be V4 over V3. So the V3 will definitely cancel since it is in a denominator. And finally, the V2's are also going to cancel. So the only two terms that will not cancel will be what? Vn plus 1 in the numerator and V1 in the denominator. Which means that Vn plus 1 divided by V1 will definitely be equal to 4 raised to the power n, since I'm multiplying 4 n times. If I multiply 4 2 times is 4 squared, 3 times is 4 cubed. 4 times is 4 to the power 4, so n times will be 4 raised to the power n. So what becomes of Vn plus 1? I just need to cross multiply, so that Vn plus 1 will give me V1 times 4 to the n. Okay, but we actually need Vn, so I need to take one step behind. So subtracting 1 from Vn from n plus 1, I'm going to get n. Subtracting 1 from n, I'm going to get n minus 1. So Vn is V1 times 4 raised to the power n minus 1. But what is V1? It's 9 divided by 2. So at the end of the day, we have Vn to be 9 over 2 times 4 to the n minus 1. I perfectly agree that this solution here will give you 3 marks. So I don't know if this solution will actually give you 3 marks. So that is why I brought up another way which we can use to find the n term of a geometric progression, having in mind that the ratio between the n plus 1 term and the n term is equal to 4, and having also the first term. Alright, so hope it helped you. If you learned something new, comment in the comment section. I'll be very happy to read your comments. Okay, so let us see the next question, which is Roman 5. Given also that all of this, Roman 5 says, show that un plus 1 minus 4un is equal to 1/3 times 2 to the n minus negative 1 to the n. Now, I don't know if most of you have solved this question before, but what I need to tell you is that the proof is wrong. Okay, this proof is not correct. Let me start by justifying. For this proof to be correct, it therefore means that if I use any value of n, for example, let me take n to be equal to 0. Okay, if n is 0, then it means that u1, because I need to replace n with 0, so u1 minus 4u0 must be equal to 1/3 into 2 to the power 0 minus negative 1 to the power 0. But when we simplify this, we are just going to have what? 3 minus 2 to be equal to 0, which is not making sense. Why? Because the right hand side here is going to give us 0. Okay, but the left hand side, our u1 was actually equal to 3, and our u0, in fact our 4u0 was equal to 2. So the left hand side is 3 minus 2, but the right hand side is 0, which is telling us that 3 minus 2, which is 1, is actually equal to 0, which is false. So this proof is incorrect. Now, when I was coming up with the video, I had a challenge. I faced a challenge, and the challenge was that I need to tell you guys that this proof is wrong, but how will I convince you or maybe come out with the right proof? Don't bother, I actually developed the correct proof, and that is what we are going to be seeing in the upcoming slides. So let us look at the proper solution to that question, where I'm going to develop the right proof to that question, and then we test and we actually confirm and affirm to the fact that the proof I'm going to give you is the correct proof. Alright, so we have that we need to show that un plus 1 minus 4un is equal to this. Like I said previously, that it is false. So we are going to develop the right proof. Okay, now we take a closer look at the hint that has been given to us. I cannot call it a hint, but the information that has been given to us. Now compare each term, un plus 1 and un. What has happened? The nth term has decreased by 1. Okay, or the n plus 1 term has decreased by 1. Now look at 4un and 4un minus 1. The nth term has also decreased by 1. Now look at 2/3 times 2 to the n and 2/3 times 2 to the n minus 1. The nth term here has also decreased by 1. So if we look at this definition, then it is very convenient for us to call the sequence on the right hand side without negative. We just define it as a new sequence. Okay, so if I let wn to be equal to that sequence, why am I doing this? I'm doing this because if I look for wn plus 1, I'm just going to have the sequence on the left hand side, because I need now to increase all the n terms by 1, and increasing all the n terms by 1 is taking me to the sequence on the left hand side. But you realize that the sequence on the left hand side is negative of the sequence wn. Okay, so this sequence here is negative of this sequence. But what is this sequence? It is wn. So at the end of the day, we have that wn plus 1 is negative wn. This is just it here, okay, because this is wn and this is wn plus 1. So wn plus 1 is negative wn. So if I divide both sides by wn, I get wn plus 1 divided by wn to be equal to negative 1. Now, negative 1 becomes the common ratio because wn is a geometric sequence or a geometric progression. So if wn is actually geometric, it therefore means that wn will be equal to the first term. Now, when you want to write the first term, the first thing to think about is, will the first term be w0 or will it be w1? Now, let us try to see if we can find w0. w0, it will give us what? u0 minus 4u of minus 1. U of minus 1 will never exist because the sequence u of n was defined for natural numbers, not integers. So the subscript can never be minus 1. It therefore means that the first term will be w1 because w1 is u1 minus 4u0 then minus 2/3 times 2 to the power 0. Okay, so that is w1. All right, so we just need to replace w1 with u1 minus 4u0 minus 2/3. Since 2 raised to the power 0 is 1, we now multiply it with the common ratio to the power n minus 1. That is the nth term of the geometric progression. We are not going to develop it like we developed previously because we are in the middle of equation, so we can just take the formula and we use it that way. Okay, now from here, now if we simplify, our u1 is 3, 4u0 we had it as 2 in the previous slide, then minus 2/3. 3 minus 2 is 1/3, 1/3 minus 2/3, sorry, 3 minus 2 is 1, 1 minus 2/3 is 1/3. So at the end of the day, this gives us wn to be 1/3 times negative 1 raised to the power n minus 1. But if you check out the proof has what? un plus 1 minus 4un, and this un plus 1 minus 4un can only be found in wn plus 1. So I need to find wn plus 1. So wn plus 1, I just need to increase n minus 1 by 1. Increasing n minus 1 by 1, I get to n. So wn plus 1 definitely is negative 1 raised to the power n divided by 3. Alright, from there now, wn plus 1 is actually equal to un plus 1 minus 4un minus 2/3 times 2 to the n, and it is also equal to negative 1 raised to the power n divided by 3. So we need a divided by 3 here. Okay, now from there, what do we have? We have that we can add 2/3 times 2 to the n on both sides of the equation, so that the right hand side becomes the negative 1 to the n divided by 3 plus 2/3 times 2 to the n. If we factorize 1/3, okay, from this term here, we are going to be left with 2 times 2 to the n. From this term here, we are going to be left with negative 1 to the n. Now, 2 times 2 to the n is 2 to the n plus 1. For me to have an n plus 1 here, I'm going to write the positive sign as 2 negative signs. Okay, negative times negative is positive, but this negative sign here, I'm going to consider it as negative 1. So this term here is going to be kind of negative 1 times negative 1 to the n. They have the same base, negative 1, so I just need to add the powers. So it's going to give me negative 1 to the n plus 1. Okay, so at the end of the day, I have what? Un plus 1 minus 4un to be 1/3 times 2 to the n plus 1 minus negative 1 to the n plus 1. Okay, so you see the error with the proof. The proof is instead 2 to the n minus negative 1 to the n. But now, for the proof to be correct, I can take one step behind. If I take one step behind, I get what? Un here, I get what? Un minus 1, I get what? 2 to the n, and I get negative 1 to the n. So it therefore means that what was supposed to be written here was rather un minus 4un minus 1 and not un plus 1 minus 4un. So this is a correct proof. I think we can even simplify, we can even try to replace terms and justify ourselves. Let us try to replace n with 1 so that we have u1 minus 4u0 to be equal to 1/3 times 2 to the power 1 minus negative 1 to the power 1. So this will actually give us 1 because what we have here is 3. 3 divided by 3 times 1/3 is 1. But if we actually carry out the operation, the operation u1 minus 4u0, we are going to get u1 as 3, 4u0 was 2, and it's also going to give us 1. So it therefore means that this is a right proof. Alright, make sure you comment in the comment section if there is something you have not understood. I'll be very happy to explain again in the comment section. Let us move on to the next part of question 9. So we are going to look at the solution to Roman 6 of question 9. Alright, so Roman 6 says, hence or otherwise deduce that 5un is equal to 9/2 times 4 to the n minus 1/3 times negative 1 to the n minus 4/3 times 2 to the n. Another wrong proof, guys. This is another wrong proof. So I am going to give you the right proof, okay? Like I'm going to develop and give you the right proof. We are going to use both hence and otherwise. And the otherwise method is a very, very interesting method that I think most of you have never seen the method before. It is a little bit long since I see 2 marks here, but it is also correct. So in cases where you are stuck, you can always verify using the otherwise method. So let us begin with the hence method. Now you have some information displayed to you. We had Vn to be equal to Un plus Un minus 1 plus 2 to the n minus 1, and we also found Vn in terms of n. And then originally, or maybe following our previous proof, like we need to use this correct proof that we had. Using the previous correct proof, we actually have this. So we are going to use these two equations to solve for the value of 5un. So why is this proof wrong? If I replace n to be 0, for example, okay, you can do the mathematics. Replace n to be 0, you are going to have 5u0 to be 9/2 minus 1/3 minus 4/3, which is 17/6. But u0 is 1 on 2, so 5u0 should give you 5 on 2. You realize that 17 on 6 and 5 on 2 are two different terms. They are not the same. So it means that the proof is not correct. So let us see how to find the correct proof. So I need to use these informations given to me. The first equation is what we just had previously, the proof we had previously, and the second equation is using the fact that Vn is equal to Un plus 1 plus Un plus 2 to the n minus 1, and it is still equal to 9 on 2 times 4 to the n minus 1. It therefore means that Un plus Un minus 1 plus 2 to the n minus 1 is equal to 9/2 times 4 to the n minus 1. Okay, now from these two equations we have to eliminate Un. Okay, we have to eliminate, either we eliminate Un minus 1 or we eliminate Un, but it's better to eliminate Un since we can just subtract the two equations. So if I take equation 1 minus equation 2, Un minus Un will give me 0. Now negative 4Un minus 1 minus Un minus 1 gives me what? Negative 5Un minus 1. Now 0 minus 2 to the n minus 1 will give me minus 2 to the n minus 1 equal to, now if I expand this bracket, I get 1/3 times 2 to the n, which is 2 to the n over 3. Then if I also expand here, I have negative 1/3 times negative 1 to the n, which will give me this. Then I need to subtract this term, so minus 9 over 2 times 4 to the n minus 1. So from here, I'm going to increase all the powers of n by 1 because the proof has 5 un. So I just need to convert n minus 1 to n minus 1 to n to n plus 1, n to n plus 1, and n minus 1 to n. We are increasing n by 1. So that's why we are converting n minus 1 to n, and we are converting n to n plus 1. Okay, from here now, what am I going to do? I just have to simplify. Negative 1, in fact 2 to the n plus 1 is the same as 2 times 2 to the n. Now negative 1 to the n plus 1 is the same as negative times negative 1 to the n. I think in the previous step you saw how I instead took the negatives, this negative here represents negative 1. I multiply with this one to get n plus 1. This time around I am bringing it back down to its original position. So doing that, I now need to add 2 to the n on both sides of the equation. So I'm going to take this quantity and I add it to 2 to the n. These two negatives here become positive. Okay, we still have this term here, and then we have this other term. If I take 2 times 2 to the n divided by 3 plus 2 to the n, I'm going to have 5 times 2 to the n on 3. Then we now add these other quantities. But since the proof is talking about 5 un, I need to divide all through by the negative sign. If I divide all through by the negative sign, I get this. Now I need to write it in order. So I begin with what? I begin with 9 over 2 times 4 to the n. Now I go to negative times negative 1 over negative 1 to the n on 3, then minus 5 times 2 to the n divided by 3. It means that the correct proof is what is displayed to you. So this is the right proof. Now I am going to show you the otherwise method, that is how we can actually analyze this sequence in a completely different way. Okay, so stay tuned. Okay, so how do I actually analyze such a sequence given to me? Now the first thing to note is that if you don't master how to solve a second order differential equation, then you cannot solve this question. So before watching this section of the solution, make sure you know about second order differential equations. Okay, if you don't know, you write in a comment section so that I can do a video on second order differential equations. But for those of you who have mastered how to solve a second order differential equation, stay with me. Okay, those of you who have not mastered, still stay with me. Those of you who have never seen, still stay with me. Okay, because this is very, very important. Like I said, it is a method that you will hardly see, but it is very correct, it's very logical, very impressive, and above all, is going to give us the correct answer. All right, so how do I use the otherwise method? First of all, I have the recursive definition of the sequence un. So I'm just going to for me to explain better, I need to have a un plus 2. You're going to know why. Okay, though I can explain it this way, but since we know about second order differential equation is having the squared y, you see the 2 is there, so that's why I need to increase all the terms of n by 1 so that here becomes un plus 2. So you're going to better understand. So here we basically increase all the terms of n by 1 so that we have un plus 2 equal to 3 un plus 1 plus 4 un then plus 2 to the n plus 1. We are increasing all the terms of n, all the terms in n by 1. Now I just need to subtract these two terms and then I equate to this other term. So think about a second order differential equation. okay, where you need to solve for the complementary function and the particular integral. So just imagine that un plus 2 is d squared y by dx squared. Imagine that un plus 1 is dy by dx, and then imagine that un is actually the y. Okay, then now the right hand side, which is always f of x, is now 2 to the n plus 1. How do you solve that second order differential equation? The first thing to do is that we find the complementary function. How do I find a complementary function? I need to solve what we call what? I need to solve the auxiliary equation. And what is the auxiliary equation? In this case, it is going to be a quadratic. R squared, where r is a root. Okay, I begin with this man. R squared minus 3r minus 4 equal to 0. We can factorize. When we factorize, we get the values of r. R is -1 and 4. So it therefore means that we have what? Real and distinct roots. If you call them r1 and r2, then generally for this recursive definition, the nth term will be a constant times the first root raised to the power n plus another constant times the second root raised to the power n. If we are dealing with differential equations, then we are going to say e to the power r1x plus b e raised to the power r2x. But here we are dealing with sequences, so it is a r1 to the n plus b r2 to the n. Okay, so in this case, our r1 and r2, you could choose -1 and 4, or 4 and -1 is still going to give you the same answer at the end of the day. So I decided to take my r1 to be -1 and my r2 to be 4. So it therefore means that un equal to a times -1 to the n plus b times 4 to the n is my complementary function. But now the right hand side is not equal to 0, so this is not homogeneous. So we need to find the particular integral, or the particular solution, or the particular sequence that solves this recursive sequence, that solves this recursive sequence equation. So how do I find the particular solution? We said that the particular solution depends on the right hand side and also on the complementary function. But you realize that there is no term that is carrying 2 to the n in the complementary function, so the particular solution will solely depend on 2 to the n plus 1 only. Okay, and 2 to the n plus 1 is actually in the form a constant times 2 to the n plus 1. Okay, it therefore means that my particular solution will be a constant times 2 to the n plus 1. Now from there, what do we have? The particular solution will always solve the recursive equation. Okay, so it therefore means I need to look for un plus 2, I need to look for un plus 1. I replace everything here. Since this particular solution is a solution, then I find the value of lambda. So un plus 1, I just need to increase the n plus 1 by 1, and then un plus 2, I need to increase the n plus 2 by 1. So it therefore means that we now need to replace un plus 2, un plus 1, and un into this equation and find the value of lambda. If we replace, the first term is lambda times 2 to the n plus 3, the second term is 3 times lambda times 2 to the n plus 2, and the third term is 4 times lambda times 2 to the n plus 1. Now we just have to simplify. 2 to the n plus 1 is 2 to the n plus 3 is 2 to the n times 2 cube. 2 cube is 8, so I multiply the 8 with lambda and I'm left with 2 to the n. I do the same thing here, where 2 to the n plus 2 is 2 to the n times 2 squared. 2 squared is 4 times 3 is 12, and then here we just have 2 to the n times 2, and the 2 times the 4 is 8. Now from here, now we can divide all through by 2 times 2 to the n, because you realize that this 2 to the n plus 1 is 2 times 2 to the n. Once we divide, here we have 4 lambda, here we have 6 lambda, here we have 4 lambda. 4 lambda minus 4 lambda is 0, so -6 lambda will be equal to 1. So lambda is -1 divided by 6. So it means the particular solution is -1 on 6 times 2 to the n plus 1, which will give us -1 on 3 times 2 to the n. If we simplify, because 2 to the n plus 1 is basically 2 times 2 to the n, and the 2 on 6 is 1 divided by 3. So we have gotten the particular solution. Now, what is a general solution? That is the general sequence. You just need to sum the complementary function with the particular solution. So my general solution is the sum of the complementary function and the particular solution. So this is my general solution. But now we have specifications, because we are not just finding a general solution, we are finding a solution that will make u1 to be 3 and u2 to be 13. So we need to replace u1 equal to 3. What does it mean? It means 3 is equal to, I replace n with 1, I replace n with 1, I get -a here plus 4b minus 2/3, because I'm replacing n with 1. If we simplify, we are going to have this equation. We call it equation x. Now, u2 is equal to 13. What does it mean? It means I replace n with 2, and I replace n with 2, and I replace n with 2, and simplify, we get the second equation. So we need to find the values of a and b, and to do that, we have to solve equation x and equation y simultaneously. Okay, so having these two equations, if I add the two equations so that a should disappear, I'm going to have 20b to be equal to 18. When you add these two, you get 18. So you divide both sides by 20, I will simplify, and b gives us 9 on 10. If you take b and you fit either in equation x or in equation y, and you simplify, you are going to get a to be -1 divided by 15, which therefore means that my un is, since it was a, -1 on 15 times this quantity plus b 9 on 10 times this quantity, then minus the particular solution. So this is the general form of u of n. Now, to prove this, I need to multiply all through by 5 so that I get 5u of n. So 5u of n, if I multiply 5 with 1 on 15, I get 1 on 3. 5 with 9 on 10, I get 9 on 2. And 5 with 1 on 3, I get 5 on 3. To write it in the required form, I just need to begin with 9 on 2. So the correct proof is 5un is equal to 9 on 2 times 4 to the n minus 1 on 3 times -1 to the n minus 5 on 3 times 2 to the n. So that is the correct proof. Alright, so guys, we have come to the end of this video. Make sure you comment the topic you want to see next in this channel. Okay, make sure you like the video, you share the video with your friends, you comment, and you also subscribe to the channel. Most importantly, when you subscribe, do well to turn on your notifications so that whenever videos are uploaded, you always be notified to come and watch. So thank you guys for watching, and see you guys in the next video. Hope you enjoyed it.